Good afternoon. Am I audible? Good afternoon. Good afternoon. Am I audible? Okay. So now, tell me where we was in the last class. If you have remembered, we was doing the discovery of proton, I think, and we have discovered also. And right now in this stage, we all know what is the mass of electron, what is the mass of proton, and we have idea about charge of electron as well as charge of proton also. Okay, very good, very nice. When electron was discovered, scientist was just curious that if negative charge particle is there, then positive also available, and they tried and they discovered positive charge particle also. And after that, they was satisfied, totally satisfied. In which manner they satisfied? They satisfied like that, ki if there is a neutral body, neutral structure, neutral body or neutral structure which is known as atom, earlier it has said it is not divisible, but right now each and everyone has information. You can divide this atom also, and inside that atom they identified first charge particle which is electron and another charge particle which is proton. Till this discovery done. After doing that much discovery, everyone happy. Everyone happy in which manner? Ki now they right now able to divide the atom also, and after discovery of electron, they discovered proton and maintain the neutrality of atom, because charge wise the electron charge and proton charge is just equal and opposite. So now they are right now able to say ki any atom, I repeat, any atom which is in neutral state, obviously atom is in neutral state, the number of electron whatever it has, same number of proton also available. Yes, it is true. The number of electron and number of proton are equal inside the neutral atom. Okay, very good. And they maintain the neutrality of the atom also. So now everyone is happy. Then further studies going on, but they observed one problem. Now from here, I am going to start the discussion of discovery of neutron, in which manner came in the picture. Till this level, till this condition, till this study, what happened? Atom is neutral. They maintain neutral also by the discovery of electron as well as proton. But right now, very, 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 very important thing. When they discovered electron and proton and started the study about atom. So first atom they have taken hydrogen atom, H atom. I have idea as well as you have also idea about hydrogen atom. You have heard that if we will represent it, so we are representing hydrogen atom like 1H1. In which manner? 1H1. We all know we all know whatever written bottom side, that is known as atomic number. Whatever is written top right corner, that is known as mass number, atomic number and mass number. What is that point, or you can say on the basis of which point, you are deciding atomic number and mass number? Am I audible? Hello. Yeah. Okay. So now, everyone ready? So where we was? We was actually doing discussion about inside the atom, electron discovered, proton discovered. Number of electron equal to number of proton. In this manner, neutrality of atom is totally verified, as well as now we can say atom has two types of charged particle. One is electron and other is proton. Everyone was happy, everything is going good, no issue, no problem. Studies, obviously, study never stops. So all the scientists at that time, they was doing their study and all. And now the time came, they started to discuss about atom, because before that, atom was considered it is the last smallest part. Inside that, nothing is available. But this time, when electron and proton discovered, now they are trying to explain the atom, their mass, their atomic number, all these things on the basis of electron and proton. Now, in that, or to discuss all these things, first example, they have taken hydrogen atom, because the first member of the periodic table is the hydrogen atom. So this is the symbol, whatever I was written earlier, hydrogen atom actually represented like this. Actually represented like that. This is the hydrogen atom. Yes. Whatever we are writing here, bottom side corner, left corner, that is known as atomic number. Maximum people has idea it is atomic number. Who don't have, this is atomic number. Now, whatever is written in the top right corner, sometimes left top corner also it will be written, this is known as mass number. Okay. For hydrogen atom, when they tried to find number of electrons are how many, or you can say how many number of electrons are present inside the hydrogen atom, how many protons are present inside the hydrogen atom, because at that time only electron and proton is available. Then what they identified, now observe it. Whatever atomic number is written, that is nothing just atomic number is nothing just equal to the number of protons. Number of protons and because the atomic number of hydrogen atom is 1, so now we can say hydrogen atom has 1 proton. So proton equal to 1 in hydrogen atom. It is very simple thing. Because atom is neutral, so that number of proton must be equal to the number of electron. So now we can say number of electron is also equal to 1 in hydrogen atom. I don't think anyone has problem in these 2 points. Okay, very good. There is a unit. One more extra point I just want to discuss with you. There is a unit which is known as atomic mass unit. You will study in this year about this unit also in detail. Atomic mass unit, AMU. Right now, these days, we are saying it unified mass also. Atomic mass unit, or these days it is known as unified mass. Sometimes I hope you have seen only U written, AMU written, or only U written. I hope you have seen in some numerical, some questions when you are doing. So that is a unit, like what is the unit of distance? Meter. Unit of mass, kg. Similarly, it is also a mass unit. But this we are using for very small particles. Very small particles. For very small particles, we are using this unit, not for heavier substance. For heavier substance, kilogram, kilogram, gram is the, you can say, generally used for the heavy substance. Atoms are very small particles which are not visible with the normal eyes. We are using for them new special unit, that is what? Atomic mass unit, or you can say unified mass. Okay. If we will say yesterday, or you can say in the previous class, we have discussed, what we have discussed? Mass of proton. Mass of proton, that was came how much? 1.67, near to that few digits are more also present. In general, we are saying 1.67 into 10 to the power minus 24 gram. But this is in grams. This is in grams. Same proton mass. In atomic mass unit, or with respect to unified mass, what we can write? So we can write it is equal to 1 AMU or 1 U. 1 U if we have written, 1 U if we have written, or 1 AMU, then we are actually representing the mass of proton in atomic mass unit. So proton mass is what? 1 AMU. While mass of electron, we are considering negligible. What is the reason to consider negligible? Already proton mass is very less. With respect to proton, electron mass is very less. So ideally, when we are doing calculation, we are not considering the mass of electron. So from today onwards, what we will do, when we will solve numerical and mass related things will come, whatever electrons are present in general, mass of electron not considered. Is it okay? So now it is clear from this point. It is clear from this point. Right now, it is a history going on. So think in your mind, atom has only two particles because neutron not discovered. So electron and proton. So what scientist will think at, what is the mindset of the scientist at that time? Ki whatever mass is actually any atom is going to show. Who is responsible for that? Proton. Because electron mass we are considering what? Negligible. So which is the person? What particle is that one which is actually responsible for the mass? We can say very easily that is proton. Okay. This discussion is going on at that time when electron and proton only discovered. And on the basis of that, when we will say what is the mass of hydrogen atom? Which atom? Hydrogen atom. So now come to the point. Hydrogen atom. Hydrogen atom. If you will observe, recently we have calculated the number of proton is equal to 1. Number of electron, obviously 1, because proton and electron must be equal so that your atom can be neutral, and mass of hydrogen atom will be how much? So because electron we are considering negligible, its mass we are considering negligible, so mass of proton must be equal to mass of hydrogen atom must be equal to total mass of protons whatever present. That should be okay. If we will see, we have idea ki mass of hydrogen atom is 1 AMU. Hydrogen atom mass is what? 1 AMU. Now we are going to what? Going to check. Is it true or not? Whatever. So mass of hydrogen atom when we are going to calculate with respect to whatever particles present inside that. So electron is, you can say electron mass is negligible mass. So only mass of proton. How many proton? 1 proton. So 1 proton into number of proton into, we can say number of proton into mass of 1 proton. Can we say or not? Yes. And electron mass, sir? Electron mass is negligible counted. Okay. If you know this, then now for hydrogen atom, we have idea, sir, proton is 1. So 1 into 1 AMU equal to 1 AMU will come. 1 AMU. And 1 AMU is what? 1 AMU is mass of proton. Mass of hydrogen atom. And practically, mass of proton also came 1 atom, 1 AMU. So it is clarified, justified also. Ki whatever they have discovered and whatever they are saying, ki atom has proton and electron, it is true. But what happened when helium atom they are going to take? Very important. Take helium atom. And now from here it will be clarify one more particle is present inside the atom. So now think about helium atom. Helium atom. Representation of helium atom He2 and here written 4. This is atomic number. Atomic number. What is this? Mass number. Mass number. And now, if you will see or count electron and proton inside the helium, because neutron we don't know, so we are able to count only what? Electron and proton. So as usual I said, atomic number is nothing, just number of proton. Atomic number is nothing, just number of protons. So now we can say number of protons in He atom equal to 2. Very simple. And we know that atom is neutral, so 2 protons. To maintain the neutrality, 2 electrons also present. So number of electron in He atom equal to 2. Can we say like that or not? Yes. Now, very important point. We all know, and at that time whatever scientist was there, they also know mass of helium atom. Mass of helium atom. Here I am writing mass of helium atom. It is equal to 4 AMU. Now problem happen. Which kind of problem happen? See this side. See this side. Very carefully. Now with this example, it will clarify one more particle is there. Number of proton 2. Number of electron 2. But mass of one helium atom 4 AMU. I told you recently electron mass is negligible. We will not count it. So mass of any atom is actually controlled by protons. How many protons helium has? 2. As per that, what should be the mass of helium atom? Helium atom mass should be 2 into proton mass. So we can say mass of helium atom should be equal to 2 proton, okay, correct, 2 proton. And what is the mass of 1 proton? 1 AMU. So it should be 2 AMU. 2 AMU. As per the electron and proton, if we will count the mass of helium atom, it should be 2 AMU. But practically, the mass of helium atom calculated 4 AMU. Problem happened. Problem, very blunder. What is that blunder? Practically, its mass coming 4 AMU. You are calculating 2 AMU. Totally wrong, not going to match, and they have observed not only with helium. Earlier they think that with helium maybe any problem is there. Same thing is going to repeat with other atoms also. Only hydrogen atom given proper response. Yes, Whatever protons are there, total proton mass equal to atom mass. That work only with hydrogen atom. Other elements not following that. Again tension came. Array, what happened? Why? Why it is not going to match? It should match. If we are saying inside the atom electron and proton are available, then its mass should be this thing, whatever difference is coming. This side observe value, and this side value whatever given, just observe. They are not going to match. It means whatever we have calculated, whatever we are thinking, that is wrong, because practical data we cannot deny. It means, neutrality of the atom is still okay. 2 proton, 2 electron, atom neutral. There no any problem is there. Problem is present in the calculation of mass. Now, again scientists came and start to think, what is this? Why? And from here one concept came in the mind. I hope this is also coming in your mind right now. One more particle present inside the atom. One more particle present inside the atom, which has zero charge. Why I am saying zero charge? Because atom neutrality with electron and proton totally possible to explain without any problem, but mass not possible. Mass is the problem. So it has said that whatever third particle is there, it has only mass. Charge wise, it is zero, neutral. And from here, the concept of neutron came in the mind. Yes, there is one more particle is present inside the atom which don't have charge, but it has mass. So everyone start again. Again experiment start, and everyone is going to run and just trying to find the new subatomic particle, which is what? Neutron. Neutron name given after that. But one concept came in the mind, something like that one more person is there. Because the neutrality of the atom is not possible to neutrality of the atom is possible to explain, but mass is not going to possible to explain with the help of only electron and proton. So that was the concept, that was the base by which discovery of neutron came in the picture. And neutron discovered in the last, the problem behind was that it is neutral. And when it is neutral, so it was never attracted any electrode side, not positive plate side, not negative plate side. So it was very problematic to identify it. Resources was very less at that time. Methods was very limited at that time. And one neutral person which is not going to attract any side. So become very, very, very problematic to identify it. But still experiments was going on, and then one scientist came in the picture whose name was James Chadwick, and he has found what? Neutron. So Chadwick came in the picture right now. Chadwick is the scientist who has done one experiment. He has bombarded alpha particle on the beryllium foil. And then he has identified one neutral particle came out, which is known as, or which was known as at that time, neutron, because it was neutral. So now about this discovery of neutron in the NCERT, only 2 lines are written. When alpha particles bombarded on the thin foil of beryllium, then they observed one neutral particle. Which kind of particle? Neutral particle that came out, and that neutral particle actually known as neutron. So now I'm just writing that statement कि when alpha particle bombarded on beryllium sheet, then one neutral particle identified, which is known as neutron, represented as N0. So neutron concept came in this manner. Now mass of neutron every scientist has calculated, and mass of neutron is nearly equal to the proton, but little higher, little more. But in general, I can say proton mass equal to neutron mass. But if order wise question will come, so now mass of neutron more than mass of proton, and comparable means nearly same also, and mass of neutron electron we know very less. So mass of electron already we have said it is negligible. So to make the mass of any atom, electron has no any role, very less role is there, so we are going to neglect it. Now we can say which is going to decide mass of an atom, which kind of particles. So proton plus neutron. So mass of any atom mass is actually controlled by mass of proton plus mass of neutron. And now when they started to explain, they get satisfactory results. In which manner? See, I am saying mass of neutron nearly equal to mass of proton. In the calculation we will use nearly same, and which I know nearly equal to 1 AMU. Okay, done. Very good. So now try to explain. I am going to explain the mass of helium atom. Now total study about helium atom again do. We know that here 2 and here 4 as a symbolic manner we are representing the helium. Number of electron equal to 2. Number of proton, obviously this will be equal to 2. They must be equal. There was the problem. We calculated previously here कि mass of helium atom should what? 2 AMU, which is wrong. How much less it is actually with the actual value? 2. It must be 4 AMU and came 2 AMU. Difference is what? 2. It means how many neutron present in the helium atom? What will you say? 2. Very good. So now we can say from here number of neutron should be what? 2. So that now if we will calculate any atom mass, so we can say mass of proton plus mass of neutron equal to mass of an atom. Observe. With respect to this data, whatever written here, we can easily say the mass of helium atom equal to mass of proton plus mass of neutron. Mass of protons plus mass of neutrons. Total 2 protons, so 2 AMU, plus total 2 neutrons, so 2 AMU more, and it is nearly equal to 4 AMU, and now it is going to justify the mass of atom. And from here, whatever we have calculated, and whatever atom you want to explain with like this, you will get satisfactory data. So this is the basic information. Until right now, we have identified inside the atom who is there? Electron, proton, and neutron is also present. And who has discovered that neutron? James Chadwick. Okay. Scientists not stopped here. So many properties are present inside the atom. They've done more and more studies. They have tried to find, they have observed few different type of properties also, and they find after that few more particles like positron, antiproton, antineutron, neutrino, etc. Sorry, so many. And their role is very less. Majorly, who is going to play the role to build the atom are electron, proton, neutron, and so that we are going to discuss about them more and more, and in our syllabus also, they three are only. Okay, other particles are not in the syllabus, so I will not discuss anything about them. If you want to see, you can search, you can find few properties are there, rotation, some has rotation different, some of the XYZ same things are there. Okay, now it is clear. One question arises, कि neutron was not discovered, but still hydrogen properties we explained very carefully. Property in the sense, carefully in the sense, we was able to explain the property of hydrogen, like charge and mass was, with the help of electron and proton, it was satisfied. It means what? It means hydrogen atom don't have neutrons. Because hydrogen atom don't have neutrons, problem not happen. Hydrogen atom was explained properly. Its neutrality explained properly. Its mass explained only with the help of proton properly. Reason? Neutron was not present. But when helium and other elements came, neutron also present inside them, and their mass was not able to explain, only with the help of proton. So that neutron discovered. Okay, very good, very nice. Now, after that, by observing all these things, which kind of question they can ask? So, 2-3 questions I just want to discuss with you. I hope you have idea right now about electron, proton, neutron, and 1-2 example I am going to discuss with you also. If we will think, again, I am going to give you short method to find the things. Like when we are saying helium atom, here written 2, here written 4, it is actually number of protons, and it is mass number. Mass number. What is mass number? Mass number is nothing, just number of protons plus number of neutron. Its sum. proton number and neutron number sum will give us mass or mass number, and atomic number is actually nothing, just what? Number of proton. Number of proton. It is known as atomic number also. Atomic number. It is equal to number of protons. In this manner, with the help of this is represented as Z and this is represented as A. With the help of Z and with the help of A, we can find electron, proton and neutron inside any atom. So few examples we will discuss. Ki number of electron, proton, neutron, how many they are present and how to count them. Then ions, what are ions and what happen when any ion form and who is the responsible to create ions, means which particle deficiency happen then ion form, or which particle increased then ion form. That discussion we will start. So now first we are trying to find few questions which are based on finding of number of electron, proton and neutron. So it is very simple. Maybe few people has idea also. Otherwise observe this side. I am writing here first helium. With helium I will start. Then carbon 6C12. Inside that we will try to find. We know 6C14 also exists. This is radioactive atom or form of carbon atom. So now we are going to discuss about these three one by one. Very simple. We all know whatever written here, that is Z atomic number, who is going to, this is equal to number of proton. Okay, so number of proton, right? In this, number of protons equal to 2. Very good. Now number of electron, as we know, if it is a neutral atom, number of electron is equal to number of protons. It will be also 2. Number of neutron, how to find? So number of neutron, if you want to calculate, it is very simple. It is A. A means neutron plus proton. It is Z. Z means proton. Proton go and subtract in the A, you will get number of neutron. Means number of neutron, if you want to find, do nothing. A minus Z, just do it. A, how much? 4. Z, 2. This difference will come 2. So here neutron is available 2. So this is the very basic method to find electron, proton, neutron. In this, it is simple. Now, what about carbon? Tell me. It is Z, number of proton. So number of proton equal to 6. Because atom is in neutral state, so number of electron also what? 6. No issue. And number of neutrons equal to, what will you say? This is A, this is Z, A minus Z, 12 minus 6 equal to 6. Simple, no issue. But think about this radioactive atom of the carbon. What will you say here? If you will go and check here, we can say number of protons equal to 6. Okay. Because it is also neutral, so number of electron also 6. Very good. But what will you say about number of neutrons? So number of neutrons equal to A minus Z. A minus Z. A minus Z means 14 minus 6. How many it will come? 8. So if 6C14 radioactive atom of carbon, inside that if anyone will ask how many neutron are present, you will say 8. In the normal carbon atom, how many neutrons? 6. This is the basic method to find electron, proton, neutron in the neutral atom. Few examples I am going to give you. You will do today all these homework in your notebook in the evening. Now, what? Find electron, proton, and neutron in given neutral atoms. First, 3Li7, 3Li7, 4Be9, 4 beryllium 9. Third, just do 7 and 14 in this. Fourth, 11 Na 23 in this also find. Wait, I'm writing little downside. Which one? Fourth. 11 Na 23. Fifth, just observe 12 Mg 24. Sixth, 13 aluminium 27. Few examples I have written here. You will solve and find electron, proton, and neutron, but they are neutral atoms. In next class when I will come, I will discuss how to find electron, proton, neutron in ionic atoms. We all know O minus 2. We have idea. We have seen O minus 2. Aluminium plus 3. Sodium plus 1. They are ions. Some are cations, some are anions. What happened with them? And what is the reason that ions generate? All these discussion we will do in the next class. Also, we will find electron, proton, neutron there, as well as some questions. Today, actually, time finished. Some questions, some numericals, some assertion reason how to solve. I will give you basic idea. Ki assertion reason problems when come, then in which manner you should think. Statement type of questions, how to think. And some basic problems, MCQ will come. Then MCQs are, I hope you have idea, but you have studied. Otherwise, how to solve MCQ also. So next class will be question discussions type, as well as ions formation, as well as in the ions how to find electron, proton, neutron. That we will also discuss. Very good. Bye-bye.